Happy holidays and welcome to the show. I'm Bret. This is my channel, and we talk about just about everything cloud and DevOps, but mostly containers. In fact, really, the containers is the new topic that we've been talking about for years now. It's almost coming up on the 7th birthday of Docker. Pretty crazy. But this is also the last show of the year and of the decade, which is kind of hard to imagine what we've gone through the last 10 years, as AWS was only a couple of years old when we started. So when we started this decade, we barely knew what cloud computing really meant. We just knew it was someone else's servers. And now we're ending this decade with a whole lot more stuff. And when I look back at this year, I was thinking about doing a year in review of just the things that happened in 2019. But everyone else kind of does that. There's lots of blog articles on that. And it was a little overwhelming just how much stuff we started with that we didn't have, and how many releases of new products, how many companies were merged or bought or split, and how many new tools showed up that we're now using, some of us in our daily workflow, that just didn't exist 12 months ago. And so let's talk about it. Let's get some questions in the chat, and we'll go through whatever you're doing in the courses that I'm giving you. In case you didn't know, by the way, Black Friday and Cyber Monday, that whole week that just happened, that is a double or triple the amount of new students. So if you're in the courses right now, you probably don't realize that that means every day we get double or triple the number of questions, that there's so much activity happening in the chat and in the Q&A. And then, of course, we're in the middle of recording new videos to add new sections to Kubernetes Mastery, and then in the next couple of months, Docker Mastery. So we're still busy. This is what we do all day, and I'm here to help. So I have no plan. I could talk about just about anything for an hour, but I thought let's just start it off with the Q&A. Instead of having a guest and you waiting until 45 minutes in to get your questions in, I thought we would just start with questions and see where it goes. So this might lead into some demos if they're easy enough for me to show you. This might just be a conversation around different tools, depending on your questions. So let's see what we got. Unfortunately, I have no skills in wrapping octal cardboard boxes. So that question has been asked, but I don't have the answer. I did see an interesting hack on using a piece of paper diagonally to wrap your boxes, and you can use less wrapping paper if you wrap them diagonally. That was on Twitter yesterday. Kind of blew my mind. 40 years of wrapping gifts, and I was doing it wrong the whole time. All right, so we've got a question around, maybe not a question, but question and a statement. I took your Kube course, and honestly, I see even less reason to use Kubernetes over Swarm. Yes, it's less opinionated, but so is iron over steel, but you don't build towers with iron. What am I missing? Well, there's a lot of factors, and I go into them in the Docker Mastery course, right? What you're probably missing the most with why should you use Kubernetes is a platform to build platforms, and Swarm was a totally different goal. It was a developer tool to make it easy to install containers and run them on multiple servers. And Kubernetes took a much wider view. They said, okay, well, let's take the parts that are common about how we run Google, and let's look at how other people are building their clouds. Because again, remember, Docker was largely about competing with cloud builders when it was invented, and then Kubernetes was a way to do that over multiple servers. So they really are, at this point, I feel like they're no longer the same tool. Yes, they both take your containers and run them on multiple servers and orchestrate, as we call it, right? But Kubernetes, it is so much more than that now. I mean, we're running it on all sorts of different environments, and it's one of those things where they're solving the problems that are hard, like hard storage problems, hard networking problems. How do I do IPv6, which Swarm doesn't do? How do I do multi-cluster federation across zones or across different availability, well, not availability zones, but different regions, sorry. And, Swarm isn't trying to solve that. Swarm isn't trying to solve the data problem or the multi-layered networking problem where you might need a lot more flexibility and policies in your network. Swarm doesn't talk to your hardware to do network configuration of the hardware to orchestrate with your orchestrator. So Swarm has a much smaller scope. It's that 80-20 rule. It takes the 80% of the features that most people need, and really it's the 20% of features that 80% of people need, I guess, because Kubernetes at this point is still a very active community, especially when you start talking about things like networks and storage, and in particular ingress. Ingress is actually something that is top of my mind for the last 2 or 3 weeks because we've been focusing on the networking part, the ingress part of the Kubernetes mastery course. And when you start talking about Kubernetes, one of the challenges with learning it is that there are the basic features, right? But then once you get into making decisions around those opinionated pieces, as you mentioned, the opinionated pieces being networking, storage, ingress, and then any third-party tools you put on top of it, it gets really hard to teach because basically in the last week, this is the example of what we dealt with. We're building out multiple ways for you to use ingress. And ingress in Kubernetes with a capital I means to bring connections into your cluster, to accept connections. But specifically in Kubernetes, it's about HTTP. Now with Swarm, we had to leave that up to vendors. We had to leave that up to Traffic, who made a great integration for Docker to allow you to route HTTP connections all around the Swarm. And now it even supports non-HTTP, so any TCP connection. And Traffic can do that, but it's Traffic specific. It's not portable to another proxy tool. If you don't want to use Traffic because maybe you have requirements for using a different one, maybe you've bought an F5 layer hardware router for Traffic, or maybe you don't want to use Traffic because it's relatively new and is untested over time, like Nginx or HA proxy. Well, with Swarm, the problem is you have to solve that problem a completely different way each time. With Kubernetes, they're trying to integrate those minimum sets of tool functionality around the whole load balancer and proxy layer. They're trying to integrate that into Kubernetes built in out of the box. And the challenge for us was that space just itself is getting so, I'm going to say the word complex, but it's multifaceted, I guess is maybe a better word, where you can use the default built-in tools of Kubernetes for ingress, but what's happened is ingress over time has not, the functionality built out of the box has not expanded yet. So we're looking for ingress v2, which is going to supposedly add more features to it. So what everyone in that space has had to do, whether you're talking about Envoy or Ingress or Traffic or, all the cloud ingress options like you have with Amazon and Azure, all of these different projects have had to solve those ingress problems different ways in Kubernetes. And they started to do that by not using the ingress controller. So what ends up happening is in order to implement ingress, you first learn ingress, the ingress controller feature specifically, and then you learn that ingress proxy. Maybe it's Traffic, maybe it's Nginx, maybe it's Envoy, whatever. And then you implement that, and then you realize that there's more features that you could use, and they would be easier to use, but you can't use them with the built-in ingress feature. So you end up having to learn about custom resource definitions and operators, and then implementing that same proxy you want to use as a different tool on top of Kubernetes, which is very similar in my experience to how Swarm would do it, because it doesn't really add on to the existing functionality of Swarm, right? But the reality is, at the end of the day, the long answer to your question is that Swarm is great and it works well until it doesn't. And I still love it. I still run my websites on it because it's simple and it solves the problems I have. The future of Swarm is a little bit uncertain, so I think some people that are choosing now are a little nervous about which orchestrator. But honestly, the number one reason today, that when I ask people, why did you choose to use Kubernetes in your company? The number one reason was I was told to use it. Or the internet told me to use it. In other words, they didn't know they had a choice, that the person that's implementing it either was told or they didn't realize that Swarm is still a viable option, because a lot of the internet is a hype, right? It's a hype cycle of marketing machines, and I'm part of that because I'm hyping whatever courses I'm trying to sell. So we're all trying to figure out what tool to use, and this is not much different than if you were to go and look at Ansible. You know, years ago, I actually chose a different tool called SaltStack, which I liked more than Ansible in Ansible's early days. But if you read the internet now, the internet would make you believe that Ansible is really the only choice for server automation, when that's clearly not the case. There's been Puppet and Chef for years. We've got other tools that are sort of leaking into the Ansible space, like CloudFormation. And so the problem is the internet doesn't always give you an unbiased opinion. And right now, the bias is that everyone should be running Kubernetes. So I think if you can use Swarm, great. There's no reason to move from it unless you find a new reason, like, oh, we've bought a product and that product only works with Kubernetes, or my manager decided that we have to run Kubernetes across the company, or we need a feature that's not in Swarm, like a built-in ingress provider, or we need more advanced storage and our storage provider only supports Kubernetes and not Docker natively. So there's lots of reasons. They're just not always obvious. I think you'll know when you need Kubernetes. It'll be because you have a problem and you can't figure out how to solve it with Swarm effectively. Yeah. Great question to start it off. All right. Is there any chance to create cluster of 2 nodes on Ubuntu using Minikube? Oops. Yeah. A cluster of 2 nodes on Ubuntu using Minikube. As far as I know, Minikube does not do multi-node. I could be wrong on that. If someone else in chat maybe has that answer that's already answered that, but I'm not sure. Multi-node, multi-node locally, you might have to use kubeadmin. I don't know. That's a good question. Whenever I need multi-node, I just spin up a couple of DigitalOcean servers or AWS servers real quick and use it, and then I tear them down. I don't ever do multi-node locally, mostly just because of resources. But and because, you know, the only thing that you really can't do on a single node Kubernetes learning setup is taints and tolerations. You can technically do them, but they're not going to do anything for you because it's not going to be able to control which node runs in one of your pods. So taints and tolerations are like Swarm constraints, where it allows you to pick the nodes or that things either won't run on or will run on. And that's really the only feature that I can think of so far that I've used that, you know, you would use locally, but you would need a multi-node setup to do. So I wish I had an answer for you. Please think about a course which covers Ansible, Jenkins, and these kinds of tools. I would love to. I need to replicate myself and have 3 different people making courses in order to do that. So yeah, thanks for the ideas. I get lots of requests for those tools, and someday, I don't know when. Probably not in 2020. If there's any new courses in 2020, they'll be focused around DevOps, the people and process, not on the tooling itself, because there's lots of courses you can take about Jenkins and Ansible. Like all those courses exist, but there's not many courses on how to implement DevOps in your organization without focusing on the tools to do it. Because so many people think that if they implement Jenkins and they automate their CI, that's DevOps, and it's not really. It's more about people and process, and the tools are used to implement those processes. And I think that a lot of the community is unclear about that, and a lot of courses focus on the tools first. So that, and the other course that I might make next year is Service Mesh. As Service Mesh gets more popular in Kubernetes, there's lots of options, and I'd like to make a course that goes through some of the most popular options. The problem is I don't know them all that well, so I'm going to have to learn them first before we do that. And I'll probably be bringing on experts to help me with that, just like with Jerome and the Kubernetes course. I'm having troubles with the egress route in OpenShift. Help. Well, I don't use OpenShift, so I'm not going to be able to help you with that on the call today. Sorry about that one. More votes for an Ansible course. I need to understand more about Kubernetes services networking, especially when we are talking about deployments on bare metal VMs with more than one nodes. Well, the networking is the basics of that are in my courses. So there will be a future section in the Kubernetes Mastery course that goes into the networking providers, the plugins, and talks about how those work on top of Kubernetes. But largely, every pod gets an IP address. You set the subnets when you set up your Kubernetes cluster, and then those all talk freely over that subnet. There's not a bunch of NAT or other fancy things going on. The different networking plugins largely choose the feature set that you're going to use. So really, to understand networking, you just spend a couple of hours on the very basics of Kubernetes networking, which is those rules. Everything has to be on a flat IP network so that your nodes and your pods can all talk to each other. Remember, every container in the same pod uses the same IP address, and that IP address is issued by Kubernetes based on a subnet, and you give it a subnet per node, and then they can dole out IPs that way. It's not using DHCP. It's simply assigning IP addresses based on the Kubernetes database, keeping track of all that. And they talk on a flat network across the nodes to each other, just using that same IP subnets. And once you start to look at using node ports, which is the load balancing service stuff that you can put in front of all those pods and services, that's when you start talking about NAT, because connections are coming from outside your cluster into your cluster. So really, the networking provider is just part of the path, because then if you start talking about ingress, that changes things up a little bit. So to truly get a full scope of all the ways that packets come in and out of your whole thing, you need to learn the networking first, the basics of networking. Then you learn choose a networking provider. Just choose a simple one, like Calico or Weave or something like that. Weave, however, does overlay networking. A couple of these options will do what's called overlay. Now, overlay is a network encapsulation layer, which takes all of your packets between the pods and stuffs them inside of UDP packets. Yeah, and uses a VXLAN feature that's native in the kernel of Linux to send those around on an overlay type network. That's the sort of term we use for that encapsulation. And then it unpacks them, turns them into the TCP or UDP packets. And this is the same way that Swarm overlay networking works. They all use the built-in features of the Linux kernel for VXLAN to allow that. Now, that's a more advanced functionality that not everyone needs. It does make certain things easier especially when your nodes are not necessarily in the same subnet with each other. But yeah, that's how you start. And then you start learning about ingress. You start learning about services and the different types of services like load balancer and node port. And that'll get you some of the way there. All right, I got Traffic 2.0 working with Swarm through Ansible. I appreciate the help in Slack. Well, great. I have not yet used Traffic 2.0, so I'm excited that I've seen a couple of people posting articles and blogs and stuff like that they're working on with Traffic 2.0. The new dashboard in 2.0 is pretty sweet, so I am very excited about the Traffic team at Containus, where they sort of redid a lot of the thinking around what a proxy and a load balancer needs to be, but that they kept the Docker and Swarm support when they implemented 2.0. Because 2.0 for Kubernetes is quite different. It actually doesn't use the default ingress provider. It actually creates a custom resource definition. And it's a little bit more work to get from 1.0 to 2.0 in Kubernetes. But in Swarm, it seems like it's largely the same. I have done clustering on cloud, but how to do on my Ubuntu with one master node? I mean, on single instance, can I run multiple nodes? Well, you can certainly run multiple VMs on your machine. The question is how do you get those connected to each other? For example, if you're using the kubeadmin utility, it will allow you to easily set up the kubelet and the networking and the certificates on each additional node so that they can talk to the master node. And I just don't know which of the local install utilities like Minikube, Micro K8s, Docker Desktop, I know doesn't do it. I haven't seen any of them yet that make it easy to just do a one-line command that sets up a second and third node. It may exist. I would check the documentation on something like Minikube. Minikube has been around the longest, I think, so if there's one that's going to have it, it might be theirs. There are other tools that you can use that are designed for more production setups. That just means that you would set up your own local VMs. So maybe you would manually create an Ubuntu VM 3 times, and then maybe use something like Kubeadmin to install Kubernetes on one, and then add the second and third nodes. And you could do that. You could do it, and you probably would learn more that way than relying on some sort of automation like Minikube. So if you're really trying to figure out multi-node clustering and how that works in a real-world scenario, use Kubeadmin and learn how that setup process goes, because it's easier now than it's ever been with Kubeadmin. But there are some steps, right? You set up that master node, and then you have to run that same Kubeadmin on additional nodes to get it all set up. And then you have to learn about things like your container engine, because you'll have to decide, do you use Docker, Containerd? So those are the things that you'll have to learn when you're going to do real-world servers. Might as well learn that on your local machine. So that's what I would do if it was me. Let's see. Have you ever had issues with large MX DNS queries on K8s with core DNS? Sorry, no. I have not run anything that actually needs MX at all in Kubernetes. Typically, well, okay, so up front, I've never run a mail server in Kubernetes. Not that you couldn't, but the internet's largely solved the mail server problem. For any apps that need to send email, I typically send them through a SMTP provider like SendGrid, so that I don't have to run a mail agent, right? So that way I wouldn't have to use the MX record. So I don't know. That's a specific to core DNS thing for sure. It's an interesting one. What is the best practices for using Kubernetes with Jenkins? I would say it largely depends on what you're trying to do, but CloudBees, the company that makes Jenkins, provides their own Kubernetes. I think they provide their own operator. So I think step one is use the operator, use the custom resource definition that CloudBees gives you to install Jenkins so that you don't have to hand install it yourself. Other than that, to me, it's just regular Jenkins. There's not much else other than that. But then again, I try to shy away from Jenkins. The only shops that I work with that would have Jenkins are ones that are already using it and not willing to use something a little more modern. Jenkins is, in this world where we now have distributed Docker builds and everything's just building a container, the complexity of Jenkins is largely unnecessary. And most of the focus of my personal work is mostly focused on GitOps, which is where the Jenkins company created Jenkins X, because they realized that the Jenkins product itself was way more than you need if the only thing you're really doing is building and testing containers and shipping them to a registry. Once you get into containerizing all your apps, a lot of the work of traditional CI/CD platforms, a lot of that work goes away because it's all happening inside the container build. And at most, it might run a Docker build and then a Docker compose up, and then maybe a Docker compose run or a couple of runs, and then if all successful, a Docker push. So anyway, yeah, Jenkins X is, but I don't really have, other than just using the standard CRDs for Jenkins, I don't have anything. Yeah, use Kind for multi-nodes. So that is definitely a good thing to do from Sujay. Hello, Sujay. Kind is the Kubernetes in Docker, so very similar to Docker in Docker. And that's also something I was going to suggest if you're using Jenkins and you need to test your apps or want to test your apps while they're running in a Kubernetes cluster, you might want to consider Kind as an easier way to do that, rather than have like Kubernetes controlling the cluster it's on, which is more complex. I wouldn't want to do that. Setting up a stream game server. Don't know anything about that. How would you say it would be to go from Swarm to Kube? It seems pretty simple for the most part, but I'm obviously new to Kube. Well, I say the two things that really depends on is, are you going to build Kube yourself, which I do not recommend you install your own Kubernetes. I recommend you use a cloud provider or a distribution that takes the work and the risk out of setting up your own cluster. So assuming you're using a cloud provider, then you just really need to know how to run the apps or build the apps so that your YAML file is correctly set up for deployments and secrets and config maps and things like the services. And you need to work out that YAML. Is in no way related to the YAML you made for Compose. Now, if you want to stick with the Docker tooling, you can look up something called Compose on Kubernetes, which uses a pod that Docker made to take your Compose file and then turn it into Kubernetes YAML and apply it to the Kubernetes API. So it doesn't support all the things that Kubernetes supports, but if you're able to use Swarm all day and you're fine with that, then that means your app fits into the limited functionality of the Compose file. And if you just want to keep those same files, then just use Compose on Kubernetes. You can look that up. That's in GitHub's under Docker's organization, github.com/docker/compose on Kubernetes. And that, if you're running Docker desktop, that's what's running in your cluster when you spin up Kubernetes in your Docker desktop. So that allows you to use Docker stack deploy against a Kubernetes cluster. There you go. Other than that, it's largely about learning the advanced functionality of Kubernetes if you want to use it. You don't have to use ingress or persistent storage or custom operators, anything like that. You can just use the default feature set and you'll be fine. Or don't use Kubernetes at all and redesign your app to run in single containers on something like Cloud Run from Google or something like that. That would be just allowing you to get out of the managing a cluster yourself completely and just run containers that talk to each other over DNS. Would it be fair to be fairly correct in saying that DevOps is more about knowing how to find an answer for your current problem than knowing how the problem was solved in the past? Well, I'm not sure if you're asking me for the definition. I would say that is not a DevOps thing. No, I would say that is being in tech. If you're in tech, you are always having to learn new ways to do things. Otherwise, you will be irrelevant and probably won't have a job. That my whole career has been nothing but a constant learning for 25 years on how to solve the same problems in a faster, easier, more reliable way. Right? 15 years ago, we were not deploying software daily for our apps because we couldn't. It took people and process, and it was very manual, and there was lots of manual human testing, and there was just a bunch of hoops you had to jump through. You had to type commands to get the servers to run the new code. You usually had to, in some cases, do manual things like untar files or write a shell script to move these files in the current directory and then make a new symlink or whatever. And that was why we couldn't deploy, every day. But now we have all these new wonderful tools. It makes it easier. It allows you to not spend your whole day manually deploying software and responding to issues that could have been self-resolved if the system would have just replaced the container, And now we have all these higher level abstractions that do all that for us. So I would say that's just being in tech. DevOps, I would say Google the definition of DevOps. DevOps is more about looking for outcomes that are business focused and using technology tools, and metrics to look at your business results and achieve a higher, a higher deployment rate so that you can deploy faster from the time that someone makes their final commit to the time that code gets into production. That should be a metric. How quickly it is that you resolve an issue if you have some sort of issue in production. That kind of stuff. That's really what DevOps is about. But somewhere along the way, we got lost in it's like automated CI/CD, which is one component of it. If you're interested more, by the way, on that kind of topic, there is a podcast that we just launched last week, or this week actually, and then a YouTube show with Laura Taco from a couple of months ago. Just look up Human Side of DevOps with my name, and you'll find Laura and I talking about what it really means to do day-to-day DevOps when you're not focused on running Kubernetes or running Jenkins, because those are really the things we use to do the goal of DevOps, which is not to just run a cluster. We had DevOps before we had containers. So, good question. Lost my place in the chat here. How to use config in Docker Swarm. I talk about that in the Docker Mastery, or maybe not Docker Mastery, maybe Swarm Mastery course on Udemy. You can get those courses. Oh, let's fix that. Not my iPad, my face. There we go. You can get my courses at bretfisher.com/courses. And config works in Docker Swarm much the way secrets do. It basically puts a file inside the container. And unlike Kubernetes will allow you to use files or environment variables, but Swarm only does files. So you would then need to take, if you need it in an environment variable for that config, or if you just needed a file, then you're fine. But if you need it in an environment variable, then you need to use a script on the container startup to take those configs and turn them into environment variables. So that's the short answer. Docs.docker.com also has good information on how to use configs in Swarm. Let's see. Some good points here on why people might choose Swarm or Kubernetes. It is definitely easier to find people that have had experience with Kubernetes, just because the market for Kubernetes is so much larger. But I would say it's also way easier to teach someone Swarm than it is to teach them Kubernetes. And if you can get away with Swarm, often you can just teach the developers in a couple of days. I mean, whenever I do Swarm workshops, we get through a majority of the features and how to use them in a day. So you can't do that with Kubernetes. Kubernetes is a 2 or 3 day workshop to do the same level of feature overview. Cody, I don't know the answer to your questions. Nodes flapping, I don't know anything about that. I don't know what plague is, actually. I don't know that word. What do I think about serverless? I think it's a great pattern if you're a greenfield. If you're developing new apps, you should seriously consider, and this is true, this has been true for all of technology's existence. We keep creating higher levels of abstraction, faster ways to program, faster ways to deploy code. And each time we do that, there are time savings. And serverless is the latest iteration of that. Right? And I would say that if you're using serverless and Golang as your programming language, that's probably about the highest level of automation and abstraction that I've seen to date. Now, that doesn't mean we're done. We're going to keep creating new ways to make things go faster. But if you're someone who's an infrastructure person, to you, serverless means I'm building a Kubernetes or Swarm cluster that's going to run a bunch of containers that will then run people's functions, and that is a self-hosted serverless. But most people are doing serverless in the cloud, and that just means you're consuming a service, a capital S service from a vendor, and you're just using their coding paradigms for how to do that. And the reality is all of those functions, or most of those functions, depending on which platform you're on, are all running in containers. So there's someone that has to run the containers and the orchestrator that will run that code. But yeah, if you can build an app that will work in the scope of functions, which, serverless means it has to support the language that you're writing in, which is not every language. And you probably should have a modern deployment model, because that's going to make serverless easier to use, because you're going to be able to quickly deploy things. That's one of the advantages, right? You don't have to do a bunch of infrastructure changes just to deploy 1,000 functions or something. You don't have to build 1,000 servers. So I think that's, we talked about this, by the way, a couple weeks ago on this channel with Kelsey Hightower. We talked about serverless, and that we're never all going to be all serverless. Just like today, we still have programs running COBOL and mainframe and 20-year-old PHP apps. Those all still exist. So we can't just all suddenly switch to serverless. The thing about containers is it allowed us to modernize the infrastructure layer of old apps, which is really great. You can take old apps, and as long as they'll run on Linux or Windows, they can be put in a container, and you can deploy them easier, you can update them easier, you can monitor them easier. And that's great. That's one of the things I really liked early on about containers, was that I didn't have to write a new app the way that this particular abstraction layer required me to run it. But serverless does that. It requires that you have to rewrite your apps or just write new apps. So the teams that I work with that are experimenting with serverless, what they're doing serverless for is to complement their existing apps, because most companies have a lot of existing code, and they're not going to rewrite that in serverless just overnight. So they have a bunch of stuff, and they're going to write serverless functions that interact with those existing apps, instead of writing more apps that are full-fledged binaries, right? And I think that is a really great way to use functions, because you don't have to worry about all the infrastructure that you traditionally had to worry about. And you don't even technically have to have a Kubernetes cluster to use serverless to run on your legacy code. So if you have legacy VMs running traditional applications, but you can call against them from a remote, endpoint, and then you can use serverless to do that. So can you put some light on best practices for backup and restore of UCP, Swarm, and DTR? So the official guide is the place I always send people. The official guide is over on, you've probably looked at this already, so this is just for everyone else. Over at success.docker.com. So at success.docker.com, we can do backup, Swarm. And you will find a bunch of guides on backup and restore best practices, backing up Swarm, backing up DTR. So like this guide right here focuses on Swarm, the Swarm database backup of the RAF database, UCP, DTR, stuff like that. So I don't have any advice beyond following this guide, because it really goes through what commands you need to run, how do you recover from those commands, what particular files you need to make sure you back up, which ones are important, which ones aren't, which backup program you use, or which automation tool you use to get those files off the servers. That's really up to you. That's not really related to Swarm or Docker. That's just, you might choose to put them in an S3 bucket on AWS if you're in the cloud using a container cluster there. It just depends on what your backup solution is. Hope that helps. What's the future look like for DevOps in 2020? Will serverless be the next big trend? So I think serverless is already a big trend in existing markets that can operate with serverless. I think what's going to have to happen for serverless to be more popular is for serverless to be baked in as an option for existing platforms. So we have Knative, which is a add-on to Kubernetes, amongst many other ones like OpenFaaS, and a lot of options for Kubernetes. But I think what's going to have to happen is that right now, unless you're in the cloud and unless your team allows you to develop serverless, you're still writing the same apps that you've always written, right? You're still writing Node apps against Node.js that are full-fledged apps and not just functions. And I think that we talked about serverless for years now, and the people that I see that are not doing it just either they don't have a good reason, they haven't come up with a good reason yet, and that's not the fault of serverless. That's just the fault of the team not wanting to rethink how they develop. A lot of people are still trying to figure out how to even do microservices. Most of the people I work with aren't even doing microservices. So I feel like the journey of going from monolith apps to distributed microservice apps to functions, you can skip over microservices if you want, but it's the mindset of someone and how they develop, how they deal with organizing their repositories, how they deal with doing this in a multi-user, in a multi-developer team, right? Those are all different things that have to happen, and everyone needs to understand the parts of their role in helping support that infrastructure. So I don't think we're going to suddenly have this huge wave of serverless in 2020. I think it's just going to be a slow trend of being another option in our toolkit. We've got lots of options for how to deploy containers, deploying non-container apps in a very flexible way, like Heroku does this. You can deploy apps on Heroku very easily, but it doesn't use containers if you don't want it to. So there's, I think, lots of options out there. I honestly don't expect anything exciting in 2020. I think that Kubernetes releases will be more boring. I think for me, seeing what comes out of the Docker team now that they are back focused on Docker tooling, or I'm sorry, on developer tooling and not server orchestration. I think that's going to be the thing that I'm most anticipating, is to see what cool stuff comes out of that team, because it's still a team of 75 developers, all focused on making life easier for development. And when you put those people together for 6 months, like, cool stuff comes out of it, right? So I'm thinking in 2020, it'll be exciting to get back to the Docker CLI and seeing what they changed with that. Docker Hub, expanding on Docker Hub functionality. I know that's one of their big goals, is to ramp back up on Docker Desktop, Docker the command line, and Docker Hub, and try to figure out how to solve more of these problems, specifically getting the tooling for running and managing Docker stuff locally. So maybe there's some new GUIs coming. Maybe there's some new functionality in Docker Desktop that allows you to manage the containers locally easier, and how to get those all together up into Docker Hub and then eventually on your servers. I don't really know yet, and I don't think they do. They're still kind of figuring out their roadmap, and I'm excited to see what they're going to do in 2020. And you will hear it first here when it comes out, because luckily they still talk to me, so I still get the Docker Captain swag, like this Q jacket. So hopefully I'll find out next year what they're doing. All right, so that's all the questions in the chat. If you have anything else, throw them in there quickly, because I won't be able to answer them for much longer. But if you are curious about what the plans are for this show, what we're going to be doing in January is we're going to start picking up the guest list again, and we're going to start having more guests on the show, and you'll start to see some new faces, but also some old faces that you've seen on this show before. And we're going to start talking more about the Kubernetes side of things. Since we launched Kubernetes Mastery a month ago, we've had thousands of people already buy it and take it. So a lot of people are asking for more stuff. And I thought, well, one way to do that, because I can only make videos so fast, is to have more people on the show about Kubernetes and talk about what they're doing in Kubernetes, which projects they think are interesting. And yeah, so expect, I think the one change is we're still going to be talking about Docker and Swarm a lot on the show next year, but there's nothing really new lately with Swarm. So you can hang out and ask your questions. We can talk about it, but largely what this show is about is what people are working on, what people are doing. So yeah, you tell me what you want to hear next year. Throw it in the comments of this video, and when we start looking at our guest list for next year, throughout the year, because we're already kind of booked for January, but when we start looking at the rest of them, let me know in the comments, and then I will see if we can get a guest on the podcast and this YouTube Live to talk about it. Let's see. Is it possible to up more than one container with a database to improve reliability? How can I configure it? I'm not sure exactly. That largely depends on which tool you're talking about. Are you using Docker, Docker Compose, Swarm, Kubernetes? But all that's possible. if you're talking about improving the reliability of a database, the answer is, what does your database technology support? Because orchestration does not replicate your database data for you. It's up to the database to do that. Container orchestration is about orchestrating at the container layer. It doesn't understand what your app is doing and do things in your app, right? And databases don't allow you to do simple file copying from one node to the other. So if you want true database redundancy, your choices are either manually set up the containers yourself and then configure their replication or their mirroring or whatever technology they have built into that database, or go look for a tool from the community or that vendor that would help you do it in containers. So there's something with Swarm that's called the autopilot pattern. So you just search autopilot pattern for containers, and you'll see some scripts and compose files and things like that that will let you set up those. If you're on the Kubernetes side of the house, you want to look up operators, also known as custom resource definitions or CRDs. A lot of the database vendors are releasing Helm charts and CRDs, which are better than the Helm charts, for managing your database. And I think when we start talking about how do I make database setup, management, clustering, auto failover, how do I make that easier? I think the future there, if you're managing these databases yourself, and I should back up and tell you that, why are you running your own databases? Run them in the cloud vendor of choice. It's way better to do that than it is to try to run them yourself. Anyway, if you have to run them yourself, then I think the future is in the operator pattern. So if you look at Kubernetes operators, like Operator Hub, and you start learning about custom resources in Kubernetes, CRDs, if you just Google that. Yeah. And this is an extension functionality. It's a feature in Kubernetes that allows you to extend Kubernetes. So it's the meta feature that allows you to make many more things in Kubernetes like Kubernetes. That means that you can take something like Operator Hub and look for your database of choice. You said Postgres. All right, so I don't know crunchy Postgres, but you could look in here and you would basically install this on a Kubernetes cluster, and it would give you new command lines and functionality for managing the deployment of your database cluster. It would manage the versions of your database cluster, and so there's going to be lots of documentation about some of the things you can do here. Now, again, each one of these you would want to look through and decide which one you want to use, because they would all have different functionality. Some are going to be more feature-rich than others. But that's what's happening, is that people are building additional functionality on the Kubernetes using this operator pattern, which the operator pattern is using a custom resource definition to allow you to operate a historically advanced piece of software like a database, some sort of clustering solution, some sort of thing that, even just Jenkins itself could be complex if you're talking about the all the different nodes that Jenkins needs to have for building things. When you start talking about that sort of stuff, it gets complicated on how to deploy it, and the operator pattern using CRDs is meant to solve that on Kubernetes. We don't really have anything like that on Swarm, so the closest you can get is Autopilot, which is really scripts and YAML for Compose that make it a little easier to set it up, but it's not going to make it to where you can update versions or deal with failover, stuff like that. Anyway, that's what I would do. Let's see. Which one product do you prefer for service mesh technology? I don't have any opinion yet because I don't use it. I don't have any customers using it. I don't know anyone who's using it heavily in production that I have had a long conversation with. So we've had people on this show about service mesh. We've had Betsy from Solo.io. So they make Glue and a bunch of other products. You can see their little... Oh, they can see Glue. And And then I like simple, so I like that Traffic is doing service mesh. It's called mesh. I pronounce it mesh because it's got the funky little A symbol in there, but it's just called mesh from Traffic, the Traffic company, and Containerus. And their goal is to make service mesh a lot more simple. And I think that is going to be a good idea, because the biggest problem right now with service mesh is that it's quite complex to get started with if you just want something really simple. So I know that Glue has their own command line utility for deploying their tools, so that makes it a little bit easier for installing it. But I don't know them all, and I've never used any of them in production myself. So I don't want to give you an opinion. I would say just go through the list and try out a few based on what you're, are you just focused purely on open source? Do you want a vendor behind it so that you could potentially buy support later on for a full business solution? That's kind of the things you would have to look at, I think. Good question. Anywhere in the Docker certification? No words on that. I ask, but we have no information yet. So, yeah, HA Kubernetes strategy for sure. I would love to talk more about HA Kubernetes at all levels. But again, it's an advanced topic, so most people, their first thing for running Kubernetes, the first thing I'm going to say is don't run it yourself. That's how you get HA. You run a cloud version, or you get a vendor and then you just run their install script on each one of your servers that sets all that up for you, like Rancher. Rancher will allow you to just basically click buttons and copy paste commands, or one of the other products. They all kind of do that to make it easier. But yeah. The complexities in Kubernetes cluster operations. I would say it all depends on whether you're running your own servers, which I usually don't recommend, or you're running a cloud-provided API, which means you don't have to worry about any of the back end. You don't have to worry about the database and backing it up. You don't have to worry about the scheduler or the Kubernetes API or any of that stuff. You just set up nodes, and you basically turn on servers and you connect them to Kubernetes with a one-line command at most. So there's the operator side of that. We're managing the servers, patching them, rebooting them, upgrading Kubernetes versions. And that's complex, right? Making sure that your cluster stays up while you're upgrading it is going to always be complex. Or you just let vendors do that for you. You let the cloud do it for you. When you get a vendored version of Kubernetes, one of the features that you want to ask that vendor about is, how do I upgrade these clusters? You will be surprised by some of the answers. Some of those answers might be you don't. You make a new cluster and you move your stuff over. That's a thing, right? Because the idea is that we're creating this infrastructure so that we can toss stuff out. So I would prefer to still try to upgrade in place, but that can be a tricky proposition if you're doing everything manually yourself. So I always recommend trying to find the easiest way to do it, like with a vendor solution, or ideally a cloud provider, because a cloud provider will hopefully upgrade it for you automatically at your leisure. The other complexity is just in writing the YAML and understanding the features of Kubernetes. Of course, anything, when it doesn't work, becomes really complex. So if you don't know how to operate the system and you don't know all the parts of the system, then troubleshooting it will be hard because you don't quite understand how all the pieces are working. That's why a lot of people recommend, if you're going to go production, walk through Kelsey Hightower's Kubernetes the Hard Way. We've talked about that a lot on this show. Kubernetes the Hard Way. And this will not be an enjoyable process. You will wish that you didn't start it and didn't do it. But there is a functioning example of how to build a Kubernetes cluster by hand, step by step, including making each certificate and moving it to the right server and all that stuff. And when you do this, it will inherently have you learning all the pieces to the puzzle and how they talk to each other. Oh, this is how my command line talks to the API. Oh, this is how the kubelet on my node talks to the API on my control plane. Stuff like that. And this is not required to run Kubernetes, because if someone else is running it for you, or if you're using a distribution, all this is done for you. But in forcing you to do this, you will learn the innards, right? Oh yeah, I have to worry about which one of my servers are running the DNS, the core DNS functionality. I have to learn more about the container runtime, which container engine I'm using, and that sort of stuff. So that forces you to do that. And if you do that, you're going to know way more about the internals, regardless of how you use Kubernetes, and that will help it make it easier for you to troubleshoot, for sure. So, yeah, more votes for high availability Kubernetes cluster. Yeah. If you're asking how to do high availability, I would say use a cloud-provided Kubernetes, or get a distribution that just allows you to click a couple of buttons and copy a command, and then that'll give you high availability. So you technically can use the kubeadmin command line to do it now. I think that feature's in beta, but that's not, even though it's a really cool tool, I would not do that for any of my customers, because unless they have like a DevOps team of 3 dedicated people to run the Kubernetes cluster, I don't want them manually installing the parts and pieces, because they really have to know how to use it before they can operate that sort of functionality without some sort of higher layer like a distribution or a cloud provided. Thanks for the K8's Mastery course. You're very welcome. I'm glad you're enjoying it. And all right, a couple more questions and then we'll be done for the year. What's the best way to pass environment variables during the swarm deploy? With Docker Compose, we use env files to store environment variables. Is there something similar in swarm mode? Well, yes. So at Docker Compose, a lot of the ways you use in Docker Compose will work in swarm. The .env file is the one that doesn't. So you can pass that env file into your shell prompt and store them as envs with a one-line command. You can probably just Google around for how to dump an env file of key and values into your shell environment. And then when you run your compose files, which have all the environment, templates in there with the mustaches, the curly brackets, that will pull in from your shell. So that's one way to do it. Of course, any templating or environment settings you have inside of your compose files themselves will do it. You can pass multiple compose files and they will override each other. So the deploy command supports overrides. There's lots of ways there to do it. But the one that it won't do is automatically pick up a .env file. So, yeah. The best tool for CI/CD on Kubernetes. Well, I'm not going to pretend to be an expert on that because there's dozens of them and I have not run them all. I would say the best one is the simplest one that meets your needs. If you're doing nothing but containers, and just because you're using Kubernetes doesn't mean you have nothing but containers. Like you could have a lot of existing infrastructure. A lot of my students and consulting clients over the years, Kubernetes and containers in general is new for them. So they have still a lot of old stuff that's not using containers yet. So when they have a CI solution, it has to support everything. It has to support old school, non-containerized apps, and now it needs to support the new containerized workflows of pushing images up to registries and stuff like that. So a lot of them do that, like one of the ones that have existed for a while. When you start talking about things like, when you talk about Argo, you're talking about GitOps, and specifically so like if this is the world of CI/CD solutions, like if Jenkins was the most functioning CI solution out there, then GitOps workflows really only need this much functionality. Like they have this very small window where they're only looking at a Git repo for changes and running commands, very simple commands in there, like building images and pushing images. And that's one type of workflow, right? They're just taking that and they're pushing it to production, or where they're pushing it to a cluster, a Kubernetes cluster specifically. So I don't have a favorite, because right now my goal is to move anybody I'm working with to a GitOps workflow, but that's largely about people and not just about tools. So I like the one from Weave, and I haven't used Tekton yet, but it's on the list for me to play with. So I think at this point, they're all fine if they're focused on a GitOps style Kubernetes workflow. And when I say GitOps, specifically what I'm talking about is that your CI automatically tracks a Git repo with whether it's using webhooks or whatever, and it's smart enough to apply your changes, and more specifically, it's smart enough to watch your Kubernetes cluster, and if changes happen, it will then post them back to that repo. We talked about that on this show a couple months ago. We talked about GitOps, and we talked specifically about tools that get you the full GitOps workflow. So that's the thing that I'm more focused on than the traditional CI/CD. For me, it's all about how easy it is. I don't want a ton of functionality. I don't need, CI agents running on a bunch of servers that will then remotely build my pipelines, stuff like that. That's what Jenkins can do, and I don't need that. I don't, not anymore, right? Because we now have remote build agents with Docker. We can deploy containers with Kubernetes to do the building. So I don't need necessarily a full-fledged CI solution like Jenkins has. So, good question. Consolidating swarm logs. Could you advise me on consolidating them in one place? Currently looking at Splunk, but it seems an overkill for me. Well, yeah, because I'm not sure what Splunk can do for free. So I would say the easiest way is the ELK solution, Elasticsearch, Logstash, and Kibana. Like if you use those, that's a way to do it and consolidate them. It's going to take up some resources, so it's not, it's free in terms of that you don't have to pay for the software, but it's going to take you some time to set it up. You're going to have to manage the space that Elasticsearch is taking up, and you're going to have to make sure you have, it cleaning up old logs so you don't fill up hard drives, and you have to worry about redundancy if you want to make sure it's available. But that's there. There are lots of other options that work on Swarm, but I think ELK is probably the most popular. I personally like to use Papertrail. Papertrail has been around forever, and they have a free plan that lets you use theirs. I prefer a service rather than run it locally on my Swarm. And depending on your needs, because here's my thought: if you can't afford to buy a service for your logging, then it's probably not for a business that's doing legitimate business. Like usually you can afford a little bit of a logging infrastructure for business purposes because it's not that expensive. But you can do something like SolarWinds has Papertrail, which I've used, 6-7 years. There's Loggly. If this is something small, just like for your personal use, ELK would probably be, the thing that you would use, or they really don't call it that much anymore, ELK. It's Elastic. The Elastic stack. But yeah, you got these 3 different parts. They now have these things called beats, which are similar to Logstash. But the point here is that this is all open source. You could use this in an unlimited way. But I really prefer to use other things like Loggly, Papertrail, Datadog. Those are tools that give me like maybe 3 or 5 servers for free. And like with Papertrail, you get a certain amount of logs for free. And then I don't have to run all that infrastructure. If you're running in the cloud might have, like AWS's logs and stuff like that. You can just use the cloud one. But yeah, good question. In the last video with Kelsey, you guys talked about next abstractions. Will these abstractions sit over Kubernetes? They may. So that question implies that there is something that will replace Kubernetes on your infrastructure. And what Kelsey really likes to talk about is that the goal here is that you don't know about your infrastructure, that you don't have to manage your infrastructure. Kubernetes is for people that want to shell into a server and manage their infrastructure. When you start looking at things like Cloud Run or other serverless abstractions, those are all probably running on some sort of clustering technology. Maybe Kubernetes, maybe not. But the point is you don't care anymore. So I would say in one way, maybe they'll run on Kubernetes, but also these abstractions since Kubernetes is, at least for the next 5 to 10 years, that's going to be the way that we're all focused on building out the most advanced clustering solution for servers. And when I say servers, I mean things that you have to shell into, that you have to care about the kernel version, and you have to patch the OS, right? If you're at that level and that's your job, then Kubernetes is the way that we're all going to be focusing on. I mean, Swarm will still be around, but again, I feel like Swarm and Kubernetes aren't even in the same league anymore. They're not, Swarm solves easy problems for simple solutions and small teams. But once you need RBAC, once you need role-based authentication, once you need all these other advanced things, you're probably going to have to go to Kubernetes. And Swarm is like Kubernetes. Swarm and Kubernetes are designed for people that have to care about a server. But these next level abstractions are really going to be at that level where you don't care about servers anymore. You're just running containers. You're just running functions. And the closest I think we see to that is stuff like we're seeing with Lambda and with Google Cloud Run, where you don't care how many cores you have, or you don't have to spin up 5 servers and then worry that they're underutilized, right? Yeah, I mean, Heroku got this right a while ago. They cut this model, but this model still kind of thinks of them as servers. They call them, well, not droplets. They call them, I can't remember. Oh, I can't remember. I forgot what Heroku calls it, but they still think of it, even though there is a modern serverless infrastructure, they still think droplets. No, droplets is, doggone it, droplets is DigitalOcean. Anyway, they still think of things as in terms of servers. And the functions world with serverless, that is largely about not having to care about infrastructure. So whatever these abstractions are, they're not going to have you shelling into a server. If you still want to do that, you're probably going to stick with Kubernetes for quite some time, right? Or just one server that's running Docker. Like, you don't have to have an orchestrator. You just run Docker, or Docker Swarm one node or something like that. But when you talk about those big infrastructure paradigms, I don't think we know yet what the next abstraction is, but running containers isolated, yes, dynos. Yeah, dynos is the right thing for Heroku. But yeah, so a lot of these things are still built around the idea of a server cluster, and I think that's what we got to get past. And in fact, if you listen to the Arrested DevOps podcast with Kelsey on it, and Kelsey and Bridget talk about this exact thing. They talk about that the next level really needs to get us beyond thinking about compute, because we don't think about the energy on servers. I used to have to be in data centers, and we used to have to plan out the energy budget for each rack to make sure that the amperage for each server wasn't overutilized. And we had this, so we had a row limit, we had a rack limit, we had 2 sides of the rack power strips. They had their limits. Each server had a limit, and we had to, I'm going to say the word orchestrate, but we didn't call it that. We had to organize all this stuff for power in the rack. But at some point, like with the cloud, that became moot. None of us care. We pay a bill. We don't know how much power we used. That's got to be where we go with compute, is we've got to get to the point where we don't know how much compute we used. We just know we got a bill, and it ran code, and we paid the bill, hopefully. Great question. Biggest issue for me in GitOps CI way is its observability. So that's kind of the point of GitOps, is that everything that's happening should be a Git log, right? It should be in the GitHub repo. If there's a change in the infrastructure, it should be in the GitHub repo. So to me, GitOps should show you observability. Like, it should improve your observability. I would almost argue that if you're not seeing better observability, then maybe the tools aren't, you're not using the tools right, or maybe the tools aren't the right tools for you. Because you're right. I would not move to a GitOps workflow if I didn't have more awareness of what was changing in my infrastructure. That to me is the big win of GitOps, is that I don't have to give someone a command line tool that they go run some obscure command to figure out what changed. They can just look at the Git log. and if you're running on GitHub or Bitbucket or something, you can just send a URL to the executive and say, hey, here's the changes that happened in our infrastructure in the last day. Here's a log of them. And it's nice and easy for them to read. Now, of course, they have to, understand like how to use diff. They can read the page in GitHub, but hopefully that's pretty obvious for them. But if you have any other ideas on that, let me know. Is there a best practice tool for metadata migration from existing on-premise workloads to the persistent storage of K8-based platforms like OpenShift? No, I don't know. I don't have any idea. I've never heard of anything. Data migration is not a solved problem. So, yeah, good question. Data's hard. It's going to be the last thing that we really solve is moving data around. Am I preparing a course for CRDs on Kubernetes? Yes, Kubernetes Mastery will have a section on operators and CRDs. That is going to come after we do the current one we're working on is ingress, and then we're going to work on persistent storage, so volumes and persistent data claims, stuff like that. And then we will hopefully do, I think the one after that we're planning on is operators and CRDs, and we'll go through some examples of using different tools and how those work. So yeah, look forward to that in the new year. I think that's it. All right. Well, thank you everyone for joining the show. This again is the last show of the year, so I'm very excited to have you all spend a little bit of your pre-holiday work schedule, or maybe you were out shopping, maybe you were taking a break from work, maybe you're at home and this is the middle of the night. Kind of depends on where you are in the world, but I'm glad that everyone was able to show up, and I will see you again in January when we start this thing back up after the holidays. So don't expect one on, the day after Christmas next week. That won't happen. I'll be enjoying some time with family. So have a great time in the holidays. I hope you get to spend some great time with friends and family, and I will see you next year on the podcast and this YouTube Live. Thanks.